We want to control our electrons, and we want to do it in such a way that it makes sense, whatever we're controlling, whether it's a computer or it's just turning on a fan or whatever it is, we want to control it, okay? So we need to understand the voltage and the current that we're seeing, because when we put something in on one end, what comes out on the other end will be of a different nature. So let's say we put in a 5-volt signal on one end and we get a 12-volt signal on the other end. We have designed our circuit such that the signal that comes in is interpreted by the circuit, and the output signal gives us something that we want to know. Maybe it's just a higher voltage to turn a relay on. Whatever it is, we have controlled it such that it will do something for us over here. It's not just mumbo jumbo that comes out. Now, when you first start looking at circuits, they just seem like mumbo jumbo. If I hold up a board, I've got a board back here. See if I got one here. Got one here somewhere. Here we go. Okay, so here you go. You guys recognize this board, right?
Yeah, it came out of a computer.
Came out of a computer. Old one. Really old one. Okay? Actually, that one's sitting right behind him. Okay, so I hold it up and it's like, okay, it's a computer board, but it's got a lot of connectors on it. And we kind of know what those connectors are, but once it goes past the connectors, then it's just pretty much in la la land, because we don't know. Unless you know something about electronics. So then you can look at it and you go, oh, let's see here. Well, there's a connector. Oh, let's see. Where's our power connector? Oh, look here. Power connection. So what would that do? Well, that would go onto the board, spread out, and it would drive the chips. It gives them power so they can make decisions. So the electrons are controlled. Well, how would they be controlled? Well, here's some drive connections. So they would control the electrons, wouldn't they? In a complex form, but still, they would. How about over here? Well, these are connected to the outside world. But still, keyboard. We can control that. Mouse. We can control that. So the connectors control the electrons that are put in the board by the power supply. And what do we get out of it? Well, there is no video, but if there was a video card here, it would have a connector that would connect to an interface so you could see what you're doing with the mouse, keyboard, and drives. Right? That's what we want to figure out. This is complex, but I can look at certain components on here, capacitors, inductors, and so on, and I can go, oh, well, you know, that probably has something to do with the power supply. These probably do. And, oh, here's some memory slots. So that has something to do with remembering things, so I can kind of figure out what those connections are. They're all discrete. They're not, once you understand them, they're not a mystery. And they all have to work properly. Now, obviously, if this is bad, I just throw it away and get another one, don't I? Because they're cheap. But some things are not. I repair processor boards for emu incubators for one of the farms out here. So they raise little emus from eggs. The machines roll the eggs and keep them at a certain humidity and a certain heat, and have a little computer board that does that. Well, just so happens that the people that built those machines went out of business. And the guy that engineered them went to South America. And I'm not kidding. There are no schematics for those, period. So guess what? When they break, I have to be able to look at the board and say, okay, it looks like here, okay, I think this part's bad, replace that part, boom, starts operating the humidifier or whatever. No schematics. So you have to understand what the board is doing.